Today we're going to look at the derivatives of exponential functions. If you recall again from Pre-Calc 30, that exponential functions are of the form y equals some base raised to the power x, and there's some restrictions on the base. It must be a positive number except 1. And remember, if the base is bigger than 1, I get an exponential graph that goes uphill, it's increasing. If the base is between 0 and 1, I get an exponential function that is decreasing. And again, we had this special number e that we talked about when we dealt with logarithms last section. And e is that constant of 2.71828, etc. When we differentiate exponential functions, we'll be dealing with two kinds, those involving the base e and those involving the base a. And when I refer to base a, it's any number that isn't e or 1. And remember, for our definition, it has to be positive. Okay, so let's take a look at a specific example, and then I'll give you the rules for the general case. Okay, so this is an exponential function. Again, how can I tell? Well, there's a variable in the exponent. Okay, so here is the pattern to take the derivative of an exponential function. The first step is the derivative of an exponential is itself. So you just rewrite the question the way it is. Then you multiply it by the derivative of the exponent, which is 3. And then we multiply it by the natural logarithm of the base. And the base in this case is 5. And that's your 3-step procedure for taking the derivative of an exponential function whose base is not e. Now, there's nothing you can do to simplify this. The biggest mistake people make is they want to multiply the 5 and the 3 together to get 15 to the 3x, but that is not allowed because the 5 has a variable in the exponent, so that is your final answer right there. So here is the general rule. Again, this is the first part where it's itself. This is the derivative of the exponent, and again, the natural log of the base. So if we take a look at question B, to find the derivative, first step is I rewrite the question as it is, so it's itself, multiplied by the derivative of the exponent, multiplied by the natural logarithm of the base, and again, there is your answer. 3 marks for these questions. In our next example, we have a product rule. Again, remember that this one is only the exponential. This one is just 3x to the 4th. So the product rule says it's my first function times the derivative of the second function. Well, the derivative of the exponential is itself times the derivative of the exponent times the natural log of the base plus the second function times the derivative of the first, which would be 12x cubed. Now I can simplify this a little bit. I have a negative 1 that can be multiplied by the 3x to the 4th. I have still my 20 raised to the 2 minus x. And I have my ln 20 plus, and I'm just going to put the 12x cubed in front. And I still have my 20 raised to the 2 minus x. Now all I'm going to do is take out my greatest common factor. Okay, and if you look, my greatest common factor, I could take out a 3x cubed for these guys, and I could take out a 20 raised to the 2 minus x. So my derivative now, I'm going to take out a 3x cubed times 20 raised to the 2 minus x. And if I take that out of my first term, I'm going to be left with a negative x ln 20 plus, and if I take a 3x cubed out of 12x cubed, I'm going to get 4, and I've taken out the 20 to the 2 minus x. So there would be your final answer. They might reverse the order of this factor, so they might write their final answer as 3x cubed, 20 to the 2 minus x, 4 minus x ln 20, but it really doesn't matter. Both answers are the same. Okay, when we get to base e's, these are actually easier because We'll go through the first example and you'll see why. Again, when I take the derivative, it's itself times the derivative of the exponent times the natural log of the base. Well, we learned in logarithms that ln e is equal to 1, so this is really irrelevant. So my final answer, I'll just bring the 3 out front, would be 3 times e to the 3x. In general, derivatives of exponentials base c are just two steps. It's basically itself times the derivative of the exponent. So in this particular case, you want to be careful with this one because you have a binomial in the exponent. So when you take the derivative, it's itself times the derivative of the exponent. And be sure to put that derivative of the exponent in brackets, because if you don't, it's going to look like just 8x being multiplied by the exponential, and we're adding 3 to that result. So make sure you put this part here in brackets. This one here, there's a couple ways to do this one, but if we apply the chain rule, I bring the 3 out front, e to the 4x plus 1 drops down to the power of 2, and then I multiply it by the derivative of the inside, which is itself, times the derivative of the exponent. Now when I clean this up, I have my 3 and my 4, so y prime is going to be 12. Now these guys have the same base, and really the exponent on this one is 1, so I could rewrite this. I leave the base alone and I add the exponents, and that would be the final answer. Alright, here's one multiple choice question, so I'll get you to pause the video and give this one a whirl. Okay, I hope you've had a chance to try that question. So hopefully you realize that we need to use the quotient rule with this question. So f prime is going to be the bottom, which is 2x, times the derivative of the top, which is itself, times the derivative of the exponent, minus the top, times the derivative of the bottom, all divided by the bottom squared. Now when we look at this answer, that clearly isn't one of the answers, but let's simplify this and see if we can get to one of the answers. So right now I can multiply this 2 and the 2x to get 4x, and I still have an e raised to the 2x minus, I'll put this 2 in front of this e to the 2x, and if I square the bottom, 2x times 2x is going to give me 4x squared. Now I could factor out a 2e to the 2x out of the numerator, and if I take out a 2e to the 2x out of the numerator, my first term will be left as 2x minus 1 all over 4x squared. And now you can see we're getting closer to some of these answers. The last thing I can do is I can simplify this 2, we'll divide into this 4 twice, and that should be my final answer. So f prime is going to be e raised to the 2x times 2x minus 1 all over 2x squared, and that matches up to the answer of e. Okay, so there's the end of this lesson. There's your assignment from your textbook. Again, answers are on the webpage. If you have any questions, feel free to send me an email.